So differential equations are kind of rough. If you remember the beginning of your calculus journey, you took differential calculus, just taking derivatives, and pretty much any function you could think of, no matter how complicated, you could write it down, and as long as you knew the rules well, you might need to use complicated things like the quotient rule, product rule, chain rule. You might need to use them all multiple times, but as long as you could write that all down, you could find the derivative. It might have been ugly, but you could do it. Then you got to integral calculus, and a lot of functions you could still integrate. Some things were hard, like for example, secant x is notoriously known for being hard. You can do it if you're very clever. That actually was an unsolved problem in math for 40 years, how to integrate secant x. And then, but there were some functions that you couldn't integrate. One famous one is 1 over the natural log of x. You try to integrate that, that actually can't be expressed in elementary functions and functions that we know. Another one is sine x over x. They make up a function, they call it sinc of x, because sine x over x doesn't have an integral expressed in elementary functions that we can talk about. Differential equations is worse. About 90% of problems you could write down, you cannot solve in differential equations. So let's see a couple examples. Okay, so let's write down what is a differential equation, first of all. Is if you have an equation with a derivative in it. It's a little weird. Like you could have, well, here's an easy one, like y prime equals x. And we want to solve for y. Or sometimes it's easier, we'll actually use this notation a lot more, dy by dx equals x. That's a very easy differential equation. We can just go ahead and solve that. Could probably, if y prime equals x, then y must be x squared over 2 plus some constant. So there's infinitely many solutions, but this is really just an integral calculus problem. A little bit harder might be, well, we could write y prime equals y. That might take some thinking, but you think about it, what function's derivative is itself? You might be able to like guess and check one solution. It may not be all the solutions. Note that this one had infinitely many solutions. But you might be able to guess and check here one solution. You might remember from calculus that if you say y equals e to the x, then its derivative is itself, and that's exactly what this equation is requiring. And we'll use this method a lot, guessing one solution in order to give us all the solutions. Great. But you can have much more complicated differential equations. Like here's, I don't know if this one has a solution. Like if you write x, y prime plus sine x equals, you know, you could even have like y prime squared. This suddenly is a lot harder. I don't know if this has a solution. Here's one that definitely doesn't. And here we can use higher order derivatives too. X squared y double prime plus x y prime plus x squared y. So this is a kind of simple one that's famous for not having a solution expressible in elementary functions. That's like the thing I mentioned earlier, the integral of sine x over x dx. You have to make up a function to be the answer to that. Same thing here. We don't have an existing function to be the answer. Okay, so this is pretty interesting field of study already. A lot of things that we want to be able to do simply cannot be done.